There's one other thing that we can do with triangles based just on distances, and that is we can do a lot of classification with them. In particular, we classify triangles based on their angles. We can make that classification just by knowing their side lengths. So, just to recall, an obtuse triangle is one where the largest angle is obtuse, which means that it's larger than a right angle, measures more than 90 degrees. A right triangle, as we've mentioned earlier, is one where the largest angle is a right angle. So a right angle measures exactly 90 degrees. And an acute triangle is one where the largest angle, and therefore all of the angles, are acute. So smaller than a right angle. They measure less than 90 degrees. So we have a right triangle if there's a right angle. If the biggest angle is bigger than a right angle, then it's an obtuse triangle. If the biggest angle is smaller than a right angle, it's an acute triangle. Now, that's about angles. How does that relate to side lengths? Well, if we have two triangles and two pairs of sides are the same length as each other, but then the third side of the first triangle is longer than the third side of the second triangle, then the angle between the equal sides is bigger on the triangle with the longer side. So that's hard to say, but easy to see in this figure. This side is longer, and this one is shorter. This angle is bigger, and this angle is smaller. Hard to say, easy to see. Okay, so shorter sides mean smaller angles, and then we can combine that with the Pythagorean theorem. So let's say we have the three sides of a triangle, and we're going to list them so that C is the biggest one. In a right triangle, the hypotenuse is always the biggest side. So if C squared, the longest side length squared, is equal to the sum of the squares of the other two, then we have a right triangle. If we make C smaller, that makes the angle smaller. So this will be an acute triangle. The angle across from C will be smaller than a right angle. And since C is the longest side, that's the largest angle, smaller than a right angle, it's an acute triangle. On the other hand, if we make C larger, that makes the angle larger. So if C squared is greater than A squared plus B squared, the triangle is obtuse. Okay, here's how we'll actually use that to classify a triangle. I've got 3 points here, A, B, and C. And I don't particularly want to draw these because I don't really want to draw an x-axis that goes out to 13 if I can avoid it. So let's see if we can figure out what kind of triangle we have on our hands without plotting these points. Well, we can find the distance from A to B, right? That's the difference in the x's squared plus the difference in the y's squared. And then we take the square root. Grabbing our calculator, we have -2 minus 1 squared plus -3 minus 1 squared is 25. So we'll have root 25. The distance from A to B is 5. BC will do the same thing. The difference in the x's, so 1 minus 13 squared plus the difference in the y's, 1 minus -4 squared, and then we take the square root. So 1 minus 13 squared plus 1 minus -4 squared is 169, and then the square root of 169 is 13. Okay, and then my AC, same thing again, difference in the x's, -2 minus 13 squared, plus difference in the y's, -3 minus -4 squared, and then we take the square root, so we'll have -2 minus 13 squared plus -3 minus -4 squared. That'll be square root of 226. Let's see if we can simplify that. And we can't, so we'll just leave it like that. Because the comparison we want to make, what we want to do is take c squared and see how it compares to a squared plus b squared. Now our c is square root of 226. So we'll square that. Well, that obviously gives us 226. Our a is 5, so we'll have 5 squared here. Our b is 13, so we'll have 13 squared here. 5 squared plus 13 squared is 194. Now 226 is greater than 194, which means that our c squared is greater than our a squared plus b squared. So comparing that to our list, or just thinking c is too long for a right triangle, we see that we're going to have an obtuse triangle with these 3 sides.